Hello and welcome back to chemistry. So we've been talking about the different types of reactions. We've talked about formation reactions and decomposition reactions. And today we're going to talk about combustion reactions. And there's two different types of combustion reactions. There's complete combustion reactions and there's incomplete combustion reactions. So we're going to start by talking about complete combustion reactions. So you've heard the term combustion before. Whenever you hear combustion, you can think of it as burning. It's just another word for burning. And to burn something, it has to be chemically reacted with oxygen. Now, most of the time, the reactions usually, like what you're reacting with oxygen, usually has carbon and hydrogen in it, and it will produce carbon dioxide and water. And this is known as a complete combustion reaction. So it's reacting with oxygen and producing CO2 and H2O. So an example would be like the one we have at the bottom there. So we see CH2O plus O2. So it's reacting with oxygen. And it's producing carbon dioxide and water. So this is a complete combustion reaction. All right, so let's look at this example. So a butane pocket lighter works by evaporating and then burning the liquid butane stored in it. Write the balanced chemical equation for this complete combustion reaction. Okay, so it says it's a complete combustion reaction, and we're given what we are reacting with, or what we're doing the combustion for, which is butane. So for all complete combustion reactions, we're always reacting whatever we're reacting with oxygen, and it's always producing carbon dioxide and water. So that's why we have it set up in the way we do there. Now we know butane is a gas because it was evaporated before it was burned. Sorry if you hear the background noise. My dog is going crazy all of a sudden. We know oxygen and carbon dioxide are both gases, and we also know the temperature that this reaction is happening at. It's very large because how else would water be able to evaporate? We know that the temp would have to be high in order for that to happen. So they're all gases. Now we need to balance the equation. So we see that there's 4 carbons on the left-hand side. That means we need to put a 4 in front of the CO2 on the right-hand side to get those to balance out. We see there's 10 hydrogens on the left-hand side, and there's only 2 on the right-hand side, so we need to put a 5 in front of the H2O. And in order to get the oxygens to balance out, we would have to put a 13 halves in front of the O2. Because there are 13 oxygens on the right-hand side. But we can't leave it like this. It cannot be in fraction form. So to get rid of the fraction, all we need to do is multiply by the denominator, which is 2. But we need to multiply everything by the denominator, or 2. So we multiply every single element in this reaction by 2. So we get 2C4H10 plus 13O2 gives us 8 CO2 plus 10 H2O. So this is something I want you to try on your own. We're going to keep going. So incomplete combustion reactions. If I start a candle burning and then cover it with a glass, the candle will eventually go out, and that's because it's used up all the oxygen in its surroundings. But if there's plenty of oxygen, then combustion continually happens. If there's no oxygen, no combustion takes place. So this is also similar to why we blow air into fires to try to help it get going, is because it needs oxygen. But what happens when we're somewhere in between? There is oxygen, there's some oxygen, but there's not a lot of it. So if a substance containing carbon and hydrogen burns in an environment where there's limited oxygen, an incomplete combustion occurs. And in these reactions, carbon dioxide is not produced. Instead, it's either carbon monoxide or just plain carbon. And that's like the two reactions we have at the top there. So let's assume that we try to burn natural gas, which is CH4, in an area where there's limited oxygen. One of two reactions happens. We either get the first reaction there, so 2CH4 plus 3O2 gives us 2CO plus 4H2O, so that's where carbon monoxide is produced. Or we get CH4 plus O2 gives us C plus 2H2O, or carbon is produced. The amount of oxygen present determines which reaction is going to happen. So if there's a good amount of oxygen around, the first reaction is going to happen, so you'll get carbon monoxide. But if you have a very limited supply, or a lot less, then you will get carbon. Now, this reaction happens all the time. And that's why it can be dangerous, because carbon monoxide is a poisonous gas. Whenever you try to burn something in a limited supply of oxygen, you run the risk of producing this poisonous gas. And like I said, this happens all the time. In order for cars to run, it needs to burn gas. And for gas to burn, a steady supply of oxygen is needed. And it usually gets this oxygen by pulling air in from the outside. Car engines, they use a lot of energy, so it has to burn a lot, because it has to burn a lot of gas. And the gas burns so fast that it depletes the oxygen in the air faster than the engine pulls it in. So when a car runs, it burns gas in a limited supply of oxygen, which is an incomplete combustion reaction. So this incomplete combustion produces carbon monoxide, and this is why you must avoid being behind a car when it's running. It's not as risky when you're like outside, obviously, but like when you're in the garage, if you leave your car running in the garage while your garage door is closed, this is very dangerous because carbon monoxide could build up in the garage and it could kill you. And actually, people have died from this before, so don't do that ever. Make sure that your garage door is open. Yeah, I mean, the amount of carbon monoxide produced by vehicles, it got to be so much of a problem that in the 70s, the government became involved because too many people were breathing in poisonous air. So in 1975, they started requiring all vehicles that were being produced to be fitted with catalytic converters. And catalytic converters help to reduce the amount of carbon monoxide in an automobile exhaust by converting the carbon monoxide to carbon dioxide. But carbon monoxide is not just produced in cars or automobiles. A lot of times when it's very cold out, some of us have gas furnaces in our houses. And natural gas furnaces have to burn their gas faster than the oxygen supply can be replenished. And this means that carbon monoxide can be produced. Fireplaces are also a source of carbon monoxide. So a lot of times there's poor airflow around a fireplace. And when the airflow is weak, the fireplace will deplete its oxygen supply to the point where incomplete combustion occurs. And many fireplaces deplete it so much that you end up having the second reaction happen, where only carbon is formed in the end. And that is why you end up getting a lot of soot in your fireplace. So the more soot that you see, the more concerned you should be about the airflow around your fireplace. What it means is that a large amount of combustion is taking place, but it's incomplete combustion. And it also means that a significant amount of carbon monoxide is being made. And once again, every year people die because their fireplaces are producing too much carbon monoxide. So make sure, ultimately, your lesson here should be to make sure that you have a carbon monoxide detector in your house. We just got one in our house because our house didn't have one, and our house is old or older. And it's always good to have one around just in case. You just never know. It's a silent and deadly gas. You can't smell it. There's no way for your senses to be able to detect it, and that's why you need to get a detector in your house. Okay, that's where we're gonna stop for today. So I hope you guys enjoy your break, and I look forward to talking with you guys soon.